And on 6.2, I want to make sure that you can evaluate polynomials, identify the general shapes of graphs and polynomial functions.
What's a polynomial?
We're going to discuss what a polynomial is, so just give me just a second. And I want you to be able to graph the polynomial function and locate the real zeros. All right, so on this one, you're given the polynomial functions, and they are written from highest exponent to lowest. So standard form of a polynomial is to write it from the highest exponent to the lowest.
Right.
So the terms that you need to make sure you know, and you should have learned them in Algebra 1, but to refresh you, should be the leading coefficient, which is the number in front of the variable with the highest exponent. Your constant term, which is a number without the variable. The variable does not affect it. The degree of each term and the degree of the polynomial.
If I get the dragon on there, Nick. No more credit.
And we are doing the degree of the polynomial. All right. So the degrees represent the exponents. And when I talk about the degree of a term, it's the exponent of each term. And terms are separated by addition, subtraction, sign. So in this example, you have 3 terms. And the degree of the polynomial is the highest exponent of your polynomial. So in this case, the degree would be 2. Thank you. And if I talk about the constant term, the constant, the number without the variable, is what, Chris? Good. And the leading coefficient would be, very good. And so that's what I'd be looking for, those terms, if I asked for it, yes. The degree of the polynomial, the whole equation, would be the highest exponent of, I'm sorry? If I asked about the degree of each term, I have 3 terms, right? So the degrees would be 2. Of the 3x, the degree would be 1. And of the constant, the degree would be, if you don't see an x, it means that that value is 0, because it's x to the 0 power, which is 1. So the next thing that we're talking about is a common type. So in your homework, it's going to ask you what's the degree, what's the type of this polynomial. And if it is a polynomial, if it is a function is what we're looking for, you'll determine if it's a constant. A constant would be like f of x or y equals a number. So like the one in here would be f of x equals 4, y equals 4. So it's a constant. So therefore, it has a degree of 0. If it has a degree of 1, it's a linear equation. F of x equals x plus 4 is an example. If it's a quadratic, we've dealt with those before. It's when you have an exponent of a 2. All right, so degree of 2. Degree of 3 would be a cubic, and it would be x to the 3rd power. And a quartic would be one with a degree of 4. And there are more, but those are the main ones that we'll be talking about. So in example 1, we want to determine whether a function is a polynomial. And if it is, we're going to write it in standard form, state its degree, the type, and the leading coefficient. Now, in order to know what is not a polynomial, or not functions, are where you have a variable in the denominator. So I'm looking to see when does the equation get, where does it stop? Where does it not keep on going forever? There's times in your functions where you have this thing called an asymptote, or a place where it's undefined. And if it's undefined or doesn't always hold true, and therefore it's not a function. So, for example, if I have 1 over x, or that's the same thing as saying x to raise to a negative number. Those are not functions. There's also ones when you have the square root as a variable. Now, you can have square roots of numbers, but when the variable's inside the square root, there's a time where it doesn't hold true. It's not true all the time. Or gives you not a real number, and you can't graph it. And if you have some number raised to a variable, that also makes it not a function. So if you have a number or a variable in the denominator, a variable with a negative exponent, a variable that's in the square root, or a variable that is used as an exponent.
So like what is it?
Well, like 2 to the x. Okay? Then that causes it not to be a function. So on A, is A considered to be a function? Okay, you think it is. What makes you think it is?
Because all the exponents are they're quadratic.
Good. All the exponents are positive, and it's not a quadratic. We want to write it in standard form, and that will help us. What's the highest exponent? With the 4, right? So that means that I have f of x, which, do you remember that that's just function notation for, okay? So that's function notation. It represents the y. And my highest exponent, we said, was x to the 4th. So you take the coefficient in front of it and its sign, and you write x to the 4th. Then the next number would be with the squares, and so you would have to do plus a half x squared. And then the next number would be the -7, which is your constant. All right, so that's part A. It asked me to write it in standard form, to state its degree. So what's the degree of this function? Okay, I want the degree of the polynomial, the general one. So it would just be one number. It would be the highest one, which is 4. All right, degree of each term, or degree of the polynomial. And I'm looking for the degree of the polynomial's degree. The type of polynomial that this is a quartic. Not a quadratic, a quartic. 4. Q-U-A-R-T-I-C. And the leading coefficient would be -3, the number in front of the highest exponent degree. All right, so let's look at B. B. Is it a function?
No.
You said no. Why? Good. There is a variable as an exponent with this 3, so it is not a function.
Why? I don't know. Why is it not a function?
Because I have x cubed, which would normally be, but it has plus 3 to the x power. And because that x is an exponent, it makes it, it's not always consistent. It doesn't keep on going forever. There's a place where it's undefined. All right, on C, you said it's not a function. Why did you say that? There is a negative exponent, which means that that variable goes to the denominator, so it's not a function. All right, and D. Function or not a function? You said not. Why? I can have a square. There is a square root, but is the variable inside the square root?
No, it is a function.
It is a function. It didn't have to be. You did see a square root, but it's only affected if there's a variable inside the square root. So it is a function. Let's write it in standard form. So the highest exponent would be?
Pi x squared.
Good. Pi x squared. The next one would be? Good. And the next thing would be? So negative square root of 2. All right. So the next thing that it asks me is, what's its degree? A 2. And if it has a degree of 2, it's a what kind of function? A quadratic. Okay. And if it's, what's its leading coefficient? Pi. Is that okay? Questions? All right, the main thing that we're looking at for today is to use refresh ourselves on functions and these terms and writing in standard form. And then also looking at the end behavior. Quadratic and a quartic? Yeah. The highest degree in a quadratic is 2, and the highest degree of a quartic is 4.
And what was the third? 3, what was it called?
The third one? Cubic. So the end behavior is what I'm looking for in this part of the lesson when you're graphing. What I'm looking for is what's happening on the ends as the graph keeps on going in both directions, to the left and to the right. What's happening to the y values? All right, so if it's a linear graph, linears make straight lines. So these first two are types of linears, linear equations. And if your slope is positive, as your graph increases, as your x values increase, so does your y's. So on the right-hand side of my graph, as my x increase, my y's increase. So as my x's go to infinity, my y values go to infinity, positive. That's what that plus little subwords 8 means. Keeps on going forever in the positive direction. But if I look at the left-hand side, as my x's go to negative infinity, my y's are going negative infinity. So I'm really just looking at my end behavior. What's happening as my x's go to infinity and negative infinity to my y's? And it works the opposite here. If you have a negative slope, your graph's going down in a linear. So as my x's go to negative infinity, my y's are doing what? Going to positive. And as my x's are going to positive infinity, my y's are going negative. We've done those before. We're very familiar with those. The next ones are quadratics, and we're somewhat familiar with those. We've talked about them. We're getting more used to them. We've seen them more often than some other ones we're going to talk about. But on quadratics, the same kind of thing. As my x goes to negative infinity, my y's are doing what? Going to positive. And on both sides, right? So that's when my a value in a quadratic, if it's positive, that's what my graph is going to be doing. And in a cubic, if it's negative, it opens down, right? So as my x's go to negative infinity, my y's are also going to negative infinity. And that's what we're looking at. We're not really looking at where the vertex point is, what's going on in the centers, not yet. We're just kind of introducing you to different types of polynomials. Now, you've seen these before. You should be fairly familiar with what they look like. But today, we're talking about any polynomials. And with any polynomials, there's some rules. And if you can remember them, they're kind of nice. And I'm going to call this one number 1 so I can refer to it down here. For any a of n, which what it means is if the first value, the leading coefficient, if the leading coefficient is positive, all right, so greater than 0, if it is positive, and the n value, your exponent, is even, all right, then as your x goes to negative infinity, your y always goes to positive. So I'm going to draw just a little graph. All right, so I have y equals some positive number times x to an even. That's what I'm really looking at. It works with any graph. And you know a quadratic, we talked about it kind of opens up. Well, that's generally what it's going to look like. It's doing this as x goes to infinity, y is going up. As x goes to positive infinity, y is going to positive infinity. Now, depending on what type of graph you have and what's the equation, the middle stuff can change, and we'll talk about that more later. I'm really only interested in the end behavior. Okay, there could be stuff, could have many turning points, many local maximums, but we're not interested in that at the moment. We're only interested in the end behavior. So if I look at the second one, when a of n is greater than 0, so again I'm looking at when it's positive, so I've got y equals a positive number, but x is raised to an odd exponent. So positive number but odd exponent. It tells me that as my x's go to negative infinity, my y's go to negative infinity. So let's draw a little graph here. And depending on your graph, there's stuff that happens in the center, okay? Could have turning points, could go up and down several times, but your end behavior is what I'm looking at. So as my x's decrease, so do my y's. So as x's go to negative infinity, my y's go to negative infinity. As my x's go to positive infinity, my y's go to positive infinity. And that's the general gist of the graph. Yes, it's not exactly. It may have some curves in there, but as it goes, the end behavior kind of looks like this. And it usually does have a little bit of a curvature in it, but not a lot. But depending on your equation. The middle stuff will change. That's why I got a little circle there, because that'll change. I'm only interested in your end behavior. All right, so the third one. When a of n is less than 0, so when it's negative, and your n is even, so you've got y equals a negative number, x, to an even exponent. Right? With a quadratic, it evens squared, right? Quadratics opened down. That's what you can remember with this one. It's going to do something to the effect even. You're going to have something to this effect where it's going down. There's stuff happening in the center, and it goes down in this direction. So as my x's go to negative infinity, my y's go to negative infinity. As my x's go to positive infinity, my y's go to negative infinity. Yes? Y equals negative, or a negative value times x raised to an even exponent. That's even. Oh, yes. And on the last one, same kind of thing, except that it's talking about when a and n is less than 0, it's negative, and the end's odd. So kind of like this one, negative exponent n is raised to an, or is an odd exponent. You have this look, kind of the opposite of the one above it. It starts off, the y value starts off positive, stuff happens in the center, and it keeps on going. Now realize it can have some curvature to it. Little curves can be different, but the general gist. As my x values go to negative infinity, my y values are going to positive infinity. As my x's are going to positive infinity, my y values are going to negative infinity. So that's the general gist of the graph. So far, okay? So the next one says, use this direct substitution to solve for f of x. I have f of x equals 7x cubed plus 9x squared plus 3x, and it says x equals 10. It may be written in that format, or it may ask you find f of 10. Same thing. That's just in function notation. So I'm going to replace the x with 10. Now, I don't do anything to this side. That's asking me, what is the function when x is 10? What's the value of the function when x is 10? I don't do anything over here. Only simplify on this side of the equations. Anytime I substitute it in, I put it inside parentheses. So that way, I remember that the negative, if it's a negative or a fraction, the exponents go with everything inside the parentheses. And I add these. That gives me 1,000 times 7, 7,000. 9 times 9, or 100 is 900. And 3 times 10 is 30. And I add them all together. So f of 10 equals 7,930. All right, so this part asked me to graph the function x cubed plus x squared minus 4x minus 1. Now, there's stuff going on in the center, but what's my end behavior going to look like? Okay, it's x to the third. Okay, so that's really what I'm looking for to give me my end behavior. X to the third, so that means it's a positive number times x raised to an odd exponent, right? So that means as f of x goes to something, as x goes to negative infinity. So odds, as x goes to negative infinity and it's a positive x cubed, what's happening? My y's are going, look at your last page, your y's are going to negative, right? So it's going to negative infinity. And as f of x goes to something, as x goes to positive infinity. All right, so does a little number like this. So it would go to positive infinity. That's your end behavior. Using your end behavior, your knowledge of that, you're going to be able to graph your functions. Now, in Algebra 2, right now, we're not that interested in figuring out the x and the y intercepts and the max and the mins. You'll get there. Right now, it's just kind of an introduction in this part. So you need to know your end behavior. When you graph them or you use a calculator, make sure that your end behavior matches what you think it should. And then that way you know if you typed it incorrectly, if you had issues. That's what I'm looking for. So when I want to graph it, what I wanted you to do, we could pick a table of values and put it in and write them out. But because we have graphing calculators at our hands, that's what I want us to use. So what I'm doing with the graphing calculators, I'm going to go into y equals, and I'm going to type in that function. I'm going to type in that same problem, which is x cubed, and you're going to use this little button beside the alpha key, the caret key to get your cubed to the third power. Now, some of your calculators have this new operating system, some of you don't. So if you have this new operating system, what I need you to do is to use your arrow key to bring it down, the cursor down to whole place. Otherwise, your calculator reads it incorrectly. If you don't have it, then you don't have the new operating system. And then plus x squared minus 4x minus 1. And I can graph it and get a picture of what it looks like. Now, we kind of talked about it, the end behaviors are what? The end behaviors would be, and that's it. Now, if I was graphing it on my paper, of course, I'm going to hit second graph to get my table of values. And if you don't have values, you have to go back to second window, which is your table set. And I want to hit auto. And then I've got my values. And you can see I'm at -3, -7. I might get one more just to make sure that it's going up and going down. And that's plenty. And I'm going to plot those points. So at -3, I'm at -7. At -2, I'm at 3. At -1, I'm at 3. At 0, I'm at -1. At 1, I'm at -3. At 2, I'm at 3. And it keeps on going. But you need to do a general gist. We know that it keeps on going farther down right here. So a little arrow going there. Kind of give it a little curvature here to this next point. Now, you know that your graph doesn't go straight across. It doesn't have a little plateau. It's going to have a little curvature to it. Now, we're not exactly sure where it goes up or goes down. I'm just going to do a little curve. We're not interested in that today. You could figure that out. There's another way of doing that. But we just want to give it a little bit of a curvature. We'll talk about finding the local max and mins later. Connect it down again, curve, curve, and back up. Now that's not the traditional x cubed graph that we talked about. However, because it has an x squared and a -4x, it affects the way that it looks. But your end behavior will be the same. As x's get to negative, so are your y's. As x goes to positive infinity, so do your y's. So this one, it's in standard form. It's a negative portrait. All right? So that means that the end behavior is going to do something in this generation. All right, so that's what's happening to my end behavior. On this one, I'm going into y equals. I'm clearing it out, and I'm typing in my function. Raised to the 4th, again, I'm pretty print, so arrow over, minus 2x to the 3rd, arrow over, plus 2x squared, plus 4x. And I'm graphing it. And we talked about the end behavior going down. Now again, there's stuff in the middle because of the -2x cubed and then plus 2x and the 4x. But that's the general gist of what the graph will look like. To graph it myself, or if I would ask you to graph it on the homework, you would hit second graph, give me a table of values, look at your values and make sure that that's what you're looking for. You'll get you enough points to get your curves. You'll get to see what the end behavior is. And those are. And if you didn't jot those down, you might want to. And then I'm at -2, 0. Now, -3, -21 goes way down here, so I just know that it's going in that vicinity. -1, -1, 0, 0, 1, 3, and 2 at -16. So 2 is way down here. My graph. All right, so do the best you can to graph it. Again, I know it's hard. You've got some curves. And that's the general gist. Now, you can change your scale of your graph when you're doing it on your own. That's perfectly fine.
I think I did that. I'm sorry.
And that's the general gist of that graph. So we knew the end behavior was going to go down. This one's a little harder. It talks about a real life situation. So no matter what of the graph, I know that I'm not going to need the negatives because I'm not going to need a negative weight for a fish, and I'm not going to need the negative length for the fish. It gives me the equation of the model, which is wonderful. Y equals 0.005x cubed. That's me to graph it and use the graph to estimate the length of a 10-pound rainbow trout. So I need to know that the weight, or at least get the weight, the Y, up to 10. And then measure across. What I did was the weight, of course, is your Y, and the length is your X, and length is in inches, and weight is in pounds. And I tried to figure out what scale I needed to use. Because I'm talking about length, and my equation is 0.0005, I thought I'm going to use bigger numbers than 1. So I did 5, 10, 15, 20, 25, 30, all the way to 40. And then on my weight, I'm wanting to get at least to 10 pounds. So I'm going to wait and see what my scale is when I do my table of values. But I'm probably thinking 5s or 10s on that also. So I've got my X value, I've got my Y values, and I'm going to use my calculator because I have it. If not, I'd pick values of X, substitute it into the X, put it into my equation, and solve for Y. So I went to Y equals, cleared out my information, and I typed in 0.0005. Make sure you always type it in correctly. Sometimes I get in a hurry and I miss a number. And I'm going to hit second graph. Now look, if I don't want to go anything below 0 because I'm not going to have negatives. But if you see 0, 0, and then I have a 1, a 2, a 3, and they're all fairly big decimals. That's where you saw in your graph, in your graphing calculator, if you used one from a previous class, is that they did the ask a value instead of using their table. And the way that you get there is by hitting second window, and I arrow down, unhighlighted auto, and hit ask. If you want it to do it auto, you'll have to do the same steps and highlight auto. I'm going to hit ask and go back to my table of values. Now there's nothing there for my X. But remember, I wanted to use 0, and it gives me my value. And I wanted to go by 5s for my X, and it gives me a value for Y. So 5, 10, 15, 20, 25, 30. And I take those values, and that's what I'm going to use to plot my graph. And you could have scrolled through all of those to do that, but you'd be scrolling for a while to get all the way to 30. So at 0, 0 is my first point. I don't care about the end behavior and the negative sides. I'm only interested in the positives. And so at the 5, I'm at 0.06. Now remember, I'm going by 5. I really actually don't want to go by 5. All right, so we go ahead and finish plotting these. Now, look at the scale here. I don't want to go by scales of 5s for the pure fact that I'm at a decimal, 1, 4, 7, 13. So maybe I'll go by a scale of 2s. So 2, 4, 6. 8, 10, and that'll get me up to 12 or 14 up here. And then I'm going to type in or plot those numbers. So at 5, I'm at 0.0625. So just really right there above the 0 line. And then at 10, I'm at 0.5 again, not very far. At 15, though, I go to 1.6. So almost to the 2. And at 20, I'm at 4. So I get to go up a little higher. At 25, I'm at 7.8. So close to the 8 marker. And then at 30, I'm all the way up to 13.5. So that's 12. 13.5 is almost to the 14. And that's kind of the general gist of my line. All right. And then I'm wanting to look to see what is the value. There's my graph. What would be an estimated value if the fish was 10 pounds? So 10 pounds is right here. What is the estimated value that it is? It would be what? So this is 25, right? This would be about what? You say 27, 28 inches. Either one of those would be fine. And that would be the general amount by your graph. You could actually find the correct answer another way, but that is just an approximation from your graph.